big sparks, you know, like a bolt of lightning.
Okay.
Lightning is a long, long spark that jumps across the sky, isn't it?
Yeah.
And I think we can produce something like that over here. So let's see if we can get the equipment all set up for that. Let's do this. Can I move this down towards you a little bit, over here? And I'm going to use this equipment over here. And now we're beginning to talk about static electricity. And I have a little cradle over here, and I have a glass rod over here, and I can rub this glass rod. And if the conditions are right in here, Mary Elizabeth, we might get some static electricity produced. I hope we do. On that one, and I have another kind over here that I'm rubbing over here, and like this. What's happening? It's pulling. It's pulling. You want to try it? You hold it there. Let's hold it like this, and I'll pull it on this side. See, it's pulling, and it's pulling back over here. See how it goes? You see, I definitely put something on there by rubbing. In other words, you can produce electricity by rubbing certain things, especially when the weather is dry and cold. All right? Have you ever heard some sparks in your hair sometimes on a cold, dry day? You're combing your hair, you can actually hear the sparks in your hair. Okay? Now, speaking of sparks, let's go over here to the big generator, and we're going to make big sparks right in here. This is a static electricity generator, and it's called a Van de Graaff generator. All right? So I have to plug it in over here, and it's going to make some sparks and a little bit noise, but don't be afraid of it, okay?
Is it going to be loud?
Not too loud. And the place to look for it is going to be right in here, you see? But I want you to see what's happening first of all. We have this ball over here, this metal ball, and it's connected with a wire over here, a strand of wire, and it's coming to this, and there's a rubberized belt that goes through here. And what it does, it picks up charge from this one and brings it that way, and it goes on the belt and it deposits it up here. So this gets charged. This would be something like the Earth and a cloud near the Earth. And you'll see a spark jump across here, which would be something like lightning. So what we're about to do is to produce something like lightning in the Kaleidoscope lab here, okay? All right, let's give it a try. Here we go. See anything yet? Okay, let's go a little faster. Come on, machine. Speed up a little. Watch right between. Oh, look at that. That's some biggies, huh? All right. Let's see if I can show you one other effect on this. I'm going to go over here and take this ring and place it like that. And here's some styrofoam. Like this. Place it over here. Watch what happens over here. Let's see what happens. Here's where you want to look. Look at that. All right. You see? What's happening is producing electricity. The static electricity is on that, and it actually pushes it away from it. All right? Okay, well, our time is about ended. During this show, my young friends and I investigated electric charge and discharge. We produced our own bolts of lightning and tried making a battery out of a lemon. Did we actually see electricity? No, we did not. But we came to understand electricity in terms of what it does. It can move meters, it can light lamps, it can operate motors, it can heat air very suddenly and produce sounds that we call thunder. Today we undertook a journey towards understanding the world of the invisible by studying the things that we see and feel and hear. So we'll see you later, and thanks a lot for watching. Goodbye. Hello there. Have you ever looked at the skies and thought about the planets rotating on their axes and orbiting the sun? And then while looking at nearby objects such as rotating bicycle wheels or spinning tops, you try to connect them in your mind, the spinning things that you play with the larger spinning things like stars and planets. Well, in order to investigate this idea a little more closely, I have invited two young friends to join me at Kaleidoscope Lab today. This is my friend Patrick, and this is Christopher. All right, Christopher, how about getting on your bicycle over here? We're going to begin talking about some spinning things. Have you ever noticed when you're riding your bicycle that after you get a little bit speed up, you can begin turning your handlebars loose?
Well, I never really tried it, but some of my friends have done it before.
Right. Well, certain kind of bicycles are really good at this. Sometimes you see a bicycle rider, he's just sitting on top of his bike like this, and just like he owns the whole world, huh? Just riding there, he just turns his handlebar loose, you see? Now, why is it that a bicycle that's still like this, it'll fall right over, you know, if you turn the handlebars loose, but if you're going down the road, you know, your speed is kind of high, you can just turn it loose and it just keeps itself going, huh? Okay, that's kind of strange. I want to show you how this happens. Over here, I have a bicycle wheel, and I can spin it or I can let it be at rest. Now, when it's at rest, I want you to see this. When we have it like this, and I just simply turn it loose, you see how it just falls? This is pretty much like the front wheel on your bicycle, right?
Yes.
Okay. You just turn one side loose, falls over. Now, how about this? How about when I get it moving like this? Okay, real fast, and then I turn one end loose. Is it going to fall? Nope. Look what happens. It does not fall. Instead, it just kind of rotates around an axis like that, see? All right, Patrick, would you get me that rope over there? Let's try the rope on it. Right over here. Let's see if we can hang it on the rope like this and see what happens. All right, just like this. You want to hold the rope?
Right.
Okay, give it a try. Watch it doesn't hit you. Hold it in here. Okay, that's strange, isn't it? Gee, it looks like it just ought to fall, huh? But it's not falling.
Yes.
Look at that going right around. Let's try it a few different ways. Let's try it, okay, keep holding the rope like this. All right, just kind of wrap it around your hand. Let's start all over now. I'm going to rotate it fast again, like this. This time, we're going to hold it way out here. Let's see what happens, if it makes any difference. All right? Don't let it hit you now. Let's go, like this. All right. All right, there we go. Look at that. It's going around quite fast, you see? Now, that's a special motion called precession. And I want to show you that when you put the rope close in like this, it doesn't do that as fast. Watch here. It precesses very slowly when it's like that. But it doesn't fall. Let's talk about that a little bit. Hold the rope again. Now watch this. I can do this like that, and it precesses. I can just let it go right around me, see? Doesn't hit me. I know it's not going to fall. When I hold it like this, it goes the opposite way. All right? Now, Christopher, this is very much like your bicycle wheel. See, after you get that bicycle going, what's happening?
Well, I really don't know.
Okay, well, it's spinning. All right? Now, what happens over here? If I try to make it go this way, it responds by going this way instead. See what I mean? I mean, if I try to make this axle point different ways, I have to fight it. Okay, you want to try it? Come over here and try it. Okay, let's start it again. Now hold it in your hands. Okay, now try to make that axle point in different ways. Kind of make it go different ways like this. Get rough with it. Come on, rough. Okay, you got to fight it, huh? It's very difficult to do, isn't it?
Yes.
Okay, now, all right, that's good. You can turn it loose. Very good. Now, what's happening over here is this bicycle wheel, when it's rotating, is behaving something like a gyroscope. You see? All of this in here wants to keep going in the same plane. And when you start doing this, you're making it go in different planes. When you take that axis and you make it point in different directions, the wheel doesn't want to do that. You got to fight it. Okay, Patrick, you want to try that? Okay. Hold it like this. Try to make it spin different ways. That's right. Change its direction. Strange, isn't it? Strange feeling.
It's like trying to control a dog when it's walking
Yes, right. You got to fight it a bit.
on a leash.
That's right. All right. Now I have a real gyroscope over here which I want to show you. So let's go this way over here at the table. We'll put this one over here and come like this. Here's a real gyroscope. And it's spinning away like mad. Now, this is nothing more than just a wheel. There's a little motor right here. See here, Christopher?
Yes.
All right. Little motor here. And the wheel is free to move in any direction, like this, or like this, or it's rotating right now. Okay, that's three kinds of motion. This is a gyroscope. Gyroscope. Have you ever heard of that word before?
I'm not sure. It sounds kind of familiar, but...
Do you know how to spell it?
Gyroscope.
Right, you got it. Gyroscope. All right. The gyroscope has three kinds of motion. The first motion is rotation. And that's what you're seeing right here, Christopher. Now, I'd like for you to come here and take that weight, Christopher, and put it right on there. Give it a try. Put it right close in on there. Can you fit that in there close? Kind of press down on it. That's right. Good. Now watch what happens. You see? It's rotating. It's kind of rotating around this vertical axis. Now, that's a different kind of motion than what you saw before. That's not rotation. This is a motion called precession. Would you like to take a guess at how you spell that?
Yes. Precession.
Oh, you got it, you got it. Okay. All right, let's try this one out. There's a third motion, and I'm going to demonstrate it to you. Okay, we have rotation and precession here, and this time I'm going to hit it. I'm going to disturb it. Watch what happens. Okay, it's kind of wobbling, oscillating, we call that. All right? That motion is called nutation. Nutation. Would you like to try that one? Nutation.
I really don't have any idea.
You don't have an idea? Okay. Christopher?
I really...
All right, I'll spell it for you. It's spelled N-U-T-A-T-I-O-N. Nutation. You see? The motion of a gyroscope is very complicated. See, it's rotating, it's precessing, and it's nutating. It's a complicated motion. That's not simple, you see? Now, don't forget your bicycle wheel is acting like a gyroscope. So the motion of your bicycle wheel gets complicated when that bicycle gets rolling down the street. You see what I mean?
Yeah.
All right. Let's try something else. This time, I'm going to pull this weight off here like this, and we're going to let it stay just like that. Now, you notice where the axle is pointing. It's pointing over here towards Patrick, right, Christopher? Now, Christopher, I want you to get in here. I want you to pick it up like this, and I want you to turn this way with it towards Patrick, and then I want you to turn towards me with it. And do it very slowly, and let's see what happens. It's pointing towards Patrick. Try it very slowly. It's kind of heavy. It's still pointing towards Patrick. Right. Come back towards me very slowly. Keep coming back. It's still pointing towards Patrick. Right?
Yes.
All right, so let's get in here. You see, the idea is when you have an object and it's rotating, it always wants to keep the axle pointing in one direction. It's almost like a compass,
Yes.
right? Okay.
Always points north.
Well, a compass always points north, but this will always point wherever you make it point to begin with, you see. In fact, they use this as a kind of gyro compass on airplanes flying over the North Pole, you see. Because a compass won't work when you're at the North Pole, right?
Yeah.
You see, a magnetic compass will point straight into the Earth or straight away from the Earth when you're at the North Pole, all right? So let's compare this now with the planet. Now let's go to the Earth over here like this. Okay, here it is, spinning away, spinning away. Okay, where are we on this, Christopher?
We're in the United States of
Okay,
America, right
point,
in there.
okay, that's fine. And we're going around like this, and it makes one rotation every day. All right. And then the sun is here. Now, Patrick, you stand over here and we'll pretend that you're the sun, right? And this is rotating, see? And it rotates day after day after day. And the sun is shining on it. And then as the seasons go by, it goes round like this, and it orbits. And it goes all the way around the sun. Okay, once a year, it goes all the way around, and it comes back like this once every year. But the interesting thing is, see the axis. You see how the axis is tilted like that? Okay, the axis is pointing at the North Star. Have you ever located the North Star at night?
Yes, it's somewhere around the Big Dipper.
That's correct. That is correct. And it's not very bright, is it?
No, it's very dim.
But it's isolated. There's not many other stars around it, correct? Right. So here's the Earth, and it's rotating around its axis like this. And that axis always wants to keep pointing in the same direction, just like the axis of that gyroscope, always pointing in the same direction, you see? Mm-hmm. And this is what's responsible for our seasons, you see? Okay? For example, the sun is shining on the Earth like this, and the Earth is tilted, the axis is tilted, you see, relative to the plane that it makes when it orbits the sun. And the sun striking more directly on the upper half of the Earth would make it very warm in the northern half of the Earth, and striking less directly down here will make it cooler.
Like winter.
Right. We'll have you know, summer up here and winter down here. You see? All right. Now let's continue on this now. There is one thing here that's very interesting, though, and a lot of people don't realize this. Does the Earth precess? The answer to that is it does. All right? You see, just like the gyroscope over here, Christopher, look, the gyroscope precesses like that. Or let's see, I could do this. The gyroscope precesses very slowly. All right? It's going very slowly, precessing. Okay? The Earth does that too. The Earth is rotating on its axis, but its axis changes direction very, very slowly. It precesses, but it takes 26,000 years for it to make one precession. You see that, Patrick?
What causes the axis to change its position?
Well, actually, what's happening is that the sun is pulling on the Earth, the sun and the other planets. They're pulling on the Earth out here, and the Earth is kind of bulging at its waist. So they tend to make the Earth, they're trying to straighten the Earth out like this. They're kind of straining on the Earth, making it go this way, see?
Like that wheel?
Yeah, like the wheel, like your bicycle wheel. When you were straining on it, it began precessing, it began doing strange things. Well, that's what's happening over here, too. In other words, 13,000 years from now, the axis of the Earth will be pointing in another direction. It will no longer be pointing at the North Star. You see? Mm-hmm. Now, of course, we won't be here to know the difference, right? Right. So during our lifetimes, it's going to be pointing pretty much at the North Star, you see? But it takes 26,000 years for the Earth to make a precession under the influence of the sun and the other planets trying to straighten it out like this to make its axis, you know, go like that. It reacts by doing this, you see, once every 26,000 years. Wow. That's a long time. That's a mighty long time, 26,000 years. Right. Okay, let's carry some more of these ideas over here of rotational motion and spinning objects. I have much more I want to show you. Let me place this right here. All right, I'm so glad you came to Kaleidoscope Lab today. We can have a lot of fun here. Let me show you this one. I'm sure you've done this many times. You know, I just have an object here in the end of a rope. I could just swing it around my head like this, right? And I can also go like this, vertically. See, here's my axis of rotation. See? Like this. All right. Have you ever noticed what happens when you spin slower and slower? You try it, Christopher. Give it a try. Whirl it vertically. That's right. Okay, let it go now. Faster, go faster. Now slow down a little bit. See what happens. Slow down. What's happening now? Slow down a little more. It doesn't work too well. Huh?
It doesn't work.
That's right. Why?
Well, because it doesn't have enough power to go around.
Mm-hmm. That's right. It doesn't have